The mean age at death of 64 men engaged in occupation is some 52.7 years with standard deviation 10.2 years. What are the 98% confidence limits for the mean age of all men in that population? So given sample size, right, mean age of death of 64 men engaged, that is sample, right, sample size n is equal to 64. Sample mean with, right, 64 men engaged in an occupation is 52.4, not 7, 52.4, that is sample mean, right, mean age, right, 52.4 years with the standard deviation, sample standard deviation small s is equal to 10.2. So what they are asking, what are the 98% confidence limit, right? Z value at 98% confidence is 2.33, right, we know, right? So Z alpha is equal to 2.33. So the 98% confidence limit formula x bar plus or minus Z alpha s by root 10, that is x bar we know 52.4 plus or minus Z alpha value 2.33 into standard deviation, sample standard deviation 10.2 by sample size root of 64. So after calculation you will get 52.4 plus or minus 2.9708. First you take, so that is plus or minus, right, in between. So take the minus value first, 52.4 minus 2.9708. So you will get the lower limit 49.4292. And you take the plus value 52.4 plus 2.9708, that is upper limit 55.3708, right, that is the confidence limit. Next problem. The weights of 1500 ball bearings are normally distributed with mean 22.40 and standard deviation 0.048. If 300 random sample of size 36 each are drawn from this population, determine the expected mean and standard deviation of the sampling distribution of means if sampling is done with the replacement. How many of the random samples in the above problem would have their means between 22.39 and 22.41? So we'll see the solution. So given if 300 random, sample size of 36 each, so sample size n is equal to 36, each draw the sample size is 36 and the total is 300, right, each sample size is 36 and the total of that type of sample sizes is equal to 300, right. So population standard deviation they have given, right, population standard deviation, right, 0.048. Population mean in the first line they have given 22.40 mu. So to find the expected mean of sample, right, so they are asking determine the expected mean and standard deviation of sample distribution. So expected value of mean sample, that is expected value of x bar. So we know expected value of x bar is equal to mu, that is a formula we know, that is equal to 22.40. Now to find the standard deviation, right, so we know standard sample standard deviation is nothing but standard error, that is equal to sigma y root n, that is equal to 0.048 by root 36, that is equal to, you will get 0.008, right. To find the number of random samples with means between 22.39 and 22.41, right. So for this first we need to find the probability of sample mean x bar lies between 22.39 and 22.41, right, mean between 22.39 and 22.41. so why, which means sample mean, right, we are we have to find the number of random samples. So we need to find n such that, that is sample mean small n, such that sample mean is lies between 22.39 and 22.41. that is what first we need to find the probability of sample mean x bar lies between 22.39 and 22.41. so that is to find x bar lies between 22.39 and 22.41, right? That is equal to probability of 22.39. we are subtracting mu with each inequality, minus mu less than x bar minus mu less than 22.41 minus mu, right? So that is equal to probability of 22.39 minus mu. We are dividing each and every term in the inequality by sigma by root n, divided by sigma by root n, less than x bar minus mu by sigma by root n, less than 22.41 minus mu by sigma by root n, right? So we know that is test statistics formula is x bar minus mu by sigma by root n, that is z, right? So in center you can put z, right? So this side we are substituting the values, 22.39 minus mu is 22.40 divided by, we know sigma by root n standard error 0.008, right? Similarly less than z less than 22.41 minus 22.40 divided by 0.008, right? So that is probability of minus 1.25 less than z less than 1.25. so this is minus area between minus 1.25 to plus 1.25. so minus to plus you are having 0 in between. So first area between minus 1.25 to 0, and other area is 0 to 1.25, right? But area is always positive, right? Whether it is in the minus side or positive side, negative side or positive side. So here area between minus 1.25 to 0 is nothing but area between 0 to 1.25, both are same. That is symmetric property of normal curve. So 2 times, right? 2 times probability of 0 less than z less than 1.25. so this is the one, z is equal to 0, this is z1 minus 1.25, this is z2 1.25 plus 1.25. so we need this area, right? Minus 1.25 to plus 1.25. so center point is 0, z is equal to 0, right? So this area is nothing but both areas are equal, right? So that is 2 into 0.3944 from the normal curve area table. So that is equal to 0.7888. Hence out of 300 samples, the required number of samples whose mean lies between 22.39 and 22.41 is 300. You multiply with 300, right? 300 into 0.7888. So you will get 236.64 approximately through 37, right? Next problem. A normal population has a mean of 0.1 and a standard deviation 2.1, right? Find the probability that the mean of a sample of size 900 will be negative. It beginning given that the probability that the absolute value of the standard normal variate exceeds 1.43 is 0.153, right? So given sample size n is equal to 900, population mean they have given 0.1, standard deviation, population standard deviation sigma is equal to 2.1. To find probability of sample mean is negative, right? Find the probability that mean of the sample of 900, right, will be negative. So sample mean is negative. That is to find probability of x bar. Negative means less than 0, right? Now probability of x bar less than 0 is nothing but subtract my mu on both sides of the inequality. So you will get probability x bar minus mu less than 0 minus mu. So and divide both the inequality by sigma by root n. So probability of x bar minus mu by sigma by root n less than 0 minus mu by sigma by root n, right? So that is z. We know z is equal to x bar minus mu by sigma by root n. So probability of z minus 0 minus mu by sigma by root n, right? So that is probability of substituting these values, right, for mu and sigma by root n, right? So that is probability of z is less than minus 1.4288, right? So z is equal to 0. This is minus 1.4286, right? This area less than means the blue marked area, right? And right side area, right side means right side to z is equal to 0, right side total area 0.5. Similarly left side area, that is also 0.5. Total area is, we know, normal curve 1, so positive side 0.5 and negative side 0.5. so left area minus area between z is equal to minus 1.4286 to z is equal to 0, right? So total area minus this area, right, z is equal to minus 1.4286 to z equal to 0. So you will get the blue marked area. So left area we know 0.5 minus probability of minus 1.4286 less than z less than 0, right? So this is nothing but right side area, because symmetric property we are using, right? Area is same, right, whether it is negative side or positive side. So this is equal to 0.5 minus probability of 0 less than z minus 1.426, right? So substitute the values, right? So you will get 0.5 minus 0.4222 from the normal curve table, that is equal to 0.0778. Hence the probability that the mean of sample of size 900 will be negative is 0.0778. Thanks.